Compression is an undeniably important aspect of mixing music. Whether we use it pragmatically or creatively, it helps to understand compression alternatives, some traditional compression settings, and creative compression methods. By the end of the video, you'll be able to use compression effectively when mixing. Let's start with alternatives to downward compression. So instead of applying downward compression, which can add both desirable and undesirable timbre alterations to the signal, we have some alternatives. For example, wave shaping could be used to bring forward quieter details. This is a good workaround for lower peaks and then increasing the output gain. I always recommend this free M wave shaper, which could introduce nearly constant amplification to quiet signals. By creating a shape in which lower amplitudes are expanded without any alteration to the peak level, we could introduce more detail without the need for peak down attenuation. Additionally, we could reduce the dynamic range with saturation, which will introduce gradual or soft knee peak down attenuation while reducing the range from the noise floor up by introducing harmonics. Now, these harmonics will typically fill the low mid to high mid ranges, resulting in reduced dynamic ranges for those aspects of the frequency spectrum. So let's take a listen to a signal with an amplified low range using wave shaping, and then we'll try the same using saturation. Keep these options in mind if you're ever looking for an alternative to compression when you're mixing. Next up, let's cover standard compression settings for various instruments. So we have a lot to run through in this section, so let's try to do it quickly, but if you have any questions, leave them in the comments and we'll get back to you. So for vocals, try a 4:1 ratio with a softer knee, a 20 millisecond attack, 50 millisecond release, a look ahead of 2 milliseconds if it's available, and then lower the threshold until you have about 6 to 8 dB of attenuation. Use makeup gain to compensate for the changes. These settings capture the vocal quickly with the attack and the look ahead in the soft knee combination, while they retain intelligibility with the 50 millisecond release, and then they bring up quieter details with makeup gain.
Don't waste my time. You talk in circles, say the same thing twice. Don't waste my time. You talk in circles, say the same thing twice.
For a kick, try a 4:1 to 8:1 ratio with a harder knee, 35 millisecond attack, and a release no longer than the next kick instance, which will change from song to song. Lower the threshold or increase the input until you achieve about 4 to 8 dB of attenuation, depending on the genre, and compensate with makeup gain. The 35 millisecond attack will let enough of the transient through while introducing some distortion that complements the hit. The release ensures that other kick hits don't get overcompressed. For the snare, try similar settings as the kick, but with a release no longer than 50 milliseconds. The same concepts apply, but try different compressor types to accent the highs. I personally like the 1176 emulation, but I encourage you to experiment. For bass, 2:1 to 4:1 ratios work well, with about 4 to 6 dB of attenuation, depending on the performance and the genre. For a smoother bass, try a higher threshold with a softer knee, a quicker attack, and a longer release of about a half note. For a punchier bass, try a lower threshold with a hard knee, a moderate attack of about 50 milliseconds, and a shorter release time. For BGVs, start with a de-esser or multiband compressor and heavily attenuate any sibilant ranges. Then use settings similar to your lead vocal, but with more attenuation overall. The goal is to control these enough to blend them in with the lead, letting the lead vocal provide the consonant and the sibilant info. Real quick, if you want to get your mixes to sound like professional songs, we have a mixing membership called the Sage Audio Membership, where you get access to Sage Audio University for in-depth mixing and mastering courses, private one-on-one mentorship, unlimited personalized mixing feedback, and 50 free mastered songs per year. Go to sageaudio.com or use the link in the description. Next up, let's cover controlling the spectral response with parallel compression. So as I mentioned earlier, compression's main purpose is to bring forward quieter details. If we do this to specific frequency ranges, we have a fantastic way to equalize a signal, much more effectively than EQ alone. For example, say I want my bass to have aggressive high frequencies. I could EQ it, or I could do the following. Step 1, create a send from the bass track and set it to unity. Step 2, insert a linear phase EQ on the corresponding auxiliary track and isolate the range that I want to affect. Step 3, heavily compress and then use makeup gain. And Step 4, blend the dense range in with the original signal using the aux tracks channel fader. Now this has helped me out more times than I can remember. Say the mids of my vocal are lacking in detail, I'll follow the same process. Or maybe the high end of the snare is being buried in the mix. Again, this will work so much better than simply equalizing the snare. So let's test this out and compare equalizing the ranges of these instruments with the parallel method that I just described. Let me know if you prefer one way over the other. Last up, let's talk about controlling creative effects with parallel compression. So effects like reverb, delay, chorusing, etc. are kind of hard to fit into a mix. Either these temporal effects overpower the entire mix, which happens a lot with reverb, or they get buried and they don't pop through when they need to. If we use parallel compression to enhance the quieter details of these effects, we can then automate them when they're needed. So say I want some more delay on the vocal that's subtle during the majority of the track, but at certain moments I want the delay to stand out. I could set up a send, use the desired effect, compress it, and then automate the aux tracks channel fader. Or say I want the reverb to sound incredibly dense. I could combine dense reflection reverb settings with compression that brings forward all of the details that would otherwise be masked. Now, parallel compression really allows us to shape the ADSR and the overall level of detail of our effects in a way that isn't possible with most, if not all, temporal effects. So let's take a listen to it and notice how much detail parallel compression can pull out of these effects. As I mentioned earlier, if you want to get your mixes to sound like professional songs, we have a mixing membership called the Sage Audio Membership, where you get access to Sage Audio University for in-depth mixing and mastering courses, private one-on-one mentorship, unlimited personalized mixing feedback, and 50 free mastered songs per year. Go to sageaudio.com or use the link in the description.